Let's practice some drawing of structures and naming using the IUPAC system. This is the compact way of writing a structure, and in order to name it, you're going to need to see it written out completely. So you need the full structural formula. So take a look. Remember, all carbons have to have 4 bonds, so get a look at what you have. You've got this carbon attached to 3 hydrogens, so that means it's got to have 1 more bond, which would probably be here. Then you've got 2 H's here. You've got 1 carbon, which is only attached to this H. So let's take a closer look at what we could have. So if I start with this one, the singular one, I know it only has 1 H. I know this is going to have to bond right here, and it has 2 H's. And then this still needs 1 more bond. That's going to be that C, and then you've got those 3 H's there. Okay. So kind of took a standpoint as to what else is this going to be connected to. Then I have a CH3 here, so if this were to come here with its 3 H's, I still have 1 bond open, and I still have 1 CH3. So that's going to come off of here, and I'm going to see this. So I have a branch. Okay, so that's my structural formula for that. Again, always double check, make sure all your carbons have 4 bonds on them. Now these are all single bonds, so it is going to be an alkane, which means it's going to end in ANE in its name. So we need to find the longest chain. Now remember, the longest chain could include a branch, so make sure you're counting carefully. So here I have 1, 2, 3, 4 if I go straight across. Or I could go 1, 2, 3, 4. The only other possibility would be here, 1, 2, 3. That's not longer, so I have 4. And all single bonds. Remember, that's butane. But is 4, ane for the single bonds. Now we have 1 branch right here, and that's a methyl group. So I know this is going to be methyl butane. But don't forget, you have to let people know where is that methyl group, which carbon is it on. And in order to do that, you're going to have to number your chain. So you could go 1, 2, 3, 4, if this is my main chain, and that would give me 3 methyl butane because it's coming off the 3rd carbon. Or if I number it this way, 1, 2, 3, 4, then it would be coming off the 2nd one, and it would be 2 methyl butane. According to the rules, you want to give all of your branches or substitutes the lowest possible number. So we're going to go with the 1, 2, 3, 4 in this direction. So this would be 2 methyl. Now remember to put a dash after the 2. 2 methyl butane. All right. Let's try this one. Okay, so here I've got that single C again. I like to start there because I want to make sure I have 4 things bonded to it. So if this is C, I know the Cl is connected to it. It needs 3 more bonds. So if I were to put this one here, CH3, that uses up that bond, and it has no other bonds, but I still have another CH3, which means that must be coming off of this one. Okay. Then I have a CH2, so if I put this C here, it has to have 2 H's on it. And then this C with its 3 H's. So they're not too bad to draw, especially if you're making sure you're watching out for the 4 bonds for the carbon. Now, same idea here, but this time looks like we have a couple branches, so we have to be careful how we name it. We have 1, 2, 3, 4, or 1, 2, 3, 1, 2, 3, 4. So it looks like 4 is going to be your longest chain again. So that is your butane. But we do have 2 groups. We have a Cl and we have a CH3. Remember, your methyls, ethyls, propyls, those will all come first. So I know I'm going to have a methyl butane. That's going to come first, but I have to tell where it's at. So once again, we need to count. You can go 1, if I'm using this as my straight chain, 1, 2, 3, 4, or 1, 2, 3, 4. They're both coming off of this carbon. It would be better if we called it a 2. So that would be 2-methyl. But now we've got to name this. Now remember, if you have halogens or any other attachment, they're going to end in an O. So this is going to be a chloro. So I'm going to put a little dash there, and it would be chloro. Squeeze that in there. And that's also on the 2, so 2. So 2-chloro, 2-methyl butane would be the answer for that one. All right, let's do one more. We have, here's that single C again. That's where I like to start, and it's got one H coming off of it, and it's got 2 bromines coming off of it, and it needs another bond. Well, I think I might have written that down incorrectly. Let me double check. Oh, I'm missing a CH in there. Here, let me rewrite this. It's supposed to be CH3, CH3, CH, CH, Br2. Now, how did I know it wasn't right? Well, if I would have put another C here with 3 H's, it wouldn't have fit. So I knew it was incorrect. Something was wrong. So if I'm working backwards, I've got that C with its H and 2, and I've got this one. So here's my C and my H. Then I've got a CH3, so I could put one right here with its 3. Then I could put one right here with its 3. Again, they get pretty big, so make sure you leave yourself plenty of room so you're not squeezing it in there too tightly. Count your chains. You can go 1, 2, 3, 1, 2, 3. Looks like no matter what, I'm going to have 3. So I'm going to go with my straight chain right here, 1, 2, 3. 3 is, remember, is prop, so I've got propane. And I have 3 branches. So this is a methyl group, so I know I'm going to have methyl first. So methyl propane. And I'm going to have 2 bromines. So when I do that part, I'm going to leave a space here for a number. This is bromo. Notice I can't fit that in there, so I'm going to slide it up here. But I have 2 of them, so you have to call it dibromo. Just like if I had 2 methyl groups, it would be dimethyl. So dibromo, and it needs a number. So we could go 1, 2, 3, and we could say 2-methyl, 3, 3-bromo, or we could go 1, 2, 3, and I could go 1, 1 dibromo, 2 methyl. So once again, it could be 2, go 3, 3, and a 2, or a 1, 1, and a 2. That's your lower combination. So 1, 1, dibromo, 2-methyl propane. So if I could write it completely out so it will fit, it would look like this. Always double check what direction you're going to go in terms of chains so that you get the correct answer. Right. From here, if you go to the book, I know I gave you some in your packet, but you can also, if you still have your book, you could do page 705, and you could do 21 through 24. All of these have the answer in the back. Let's try working backwards. I didn't show you any of those, and that's number 24. So I'm just going to take one of them from number 24, where they give you the name and ask you to draw the structure. So we have 3-ethyl, 2,4-dimethyl, pentane. Okay. I think this way is a little bit easier, going this route instead of starting with the structure and naming. So because I've got my parent name, that's where I start. Pent is 5, so I'm going to go 1, 2, 3, 4, 5. And I'm just going to let it go. I'm going to let this be number 1, 2, 3, 4, 5. So it's nice and simple, nice and straightforward. And then I'll just go across. So I have 3 ethyl. So off of my third carbon, I have an ethyl. Remember, F means 2. So off my third carbon, I have to have 2 carbons. So that's ethyl. Then, off of carbon number 2, I need a methyl. And off of carbon number 4. Now you can draw these at the top or you can draw them at the bottom, however you want to do it. A lot of times people will draw these in the bottom just to give us some more space. Now, we're not done because we don't have our hydrogens in there. So remember, every carbon has to have 4 bonds. This one only has 1, so put in 3 hydrogens. This one already has 3, so it needs 1 more hydrogen. This one needs 3 hydrogens. This needs 1 hydrogen. This needs 2, and you can see how it gets squeezed in there. So it's so a lot of times they'll draw this a little bit longer so you can fit that in there. This one still needs 1 more. This needs 3. And you can kind of see why they would want to condense those into the forms that we saw earlier up here. Because you can fit it on a piece of paper much easier than you can this picture. So this structural formula represents 3-ethyl 2,4-dimethylpentane.